Introducing the Beacon, the latest advancement in medical technology that helps people dealing with some of today's toughest cranial health challenges, from epileptic seizures to cerebral palsy. This novel cranial helmet provides better protection and shock absorption than current helmets on the market and was inspired by the toucan's colorful beak, which is known for its shock absorption abilities. This protective cranial helmet is designed to have an exterior lined with scattered, overlapping carbon scales and a fibrous foam layer underneath it, just like the toucan's beak.
When I say toucan, what pops up in your head? Is it an image of the rainforest, maybe its colorful beak, or perhaps the fruity cereal it inspired? Well, as it turns out, the toucan's beak has amazing properties that aren't limited to just mascotting a cereal. The toucan's beak measures to be 1/3 of the bird's length, yet only 1/20th of its mass, and is used for eating fruits, insects, and carving nests in trees. In an effort to discover the key behind the stiffness of the toucan's beak, researchers sectioned the beak and performed numerous tests on strength, structure, and hardness. What they discovered is that the beak has an exterior composition similar to claws that work synergistically with a closed cell system interior. That, along with the viscoelastic glue, allows for different responses to different amounts of stress. Our helmet, Beacon, takes inspiration from these findings to better protect the wearer's head. Using a lightweight carbon scale exterior, Beacon works synergistically with a shock-absorbing interior that models the closed cell system of a toucan. Beacon also prevents crack propagation from local damaged regions. So how is Beacon like a toucan's beak? Just as toucans can fly with such large beaks, Beacon wearers will also be able to move quite freely. With safety as well as comfort in mind, we aim to produce a helmet that even toddlers can wear effortlessly. The foam layer results in high specific stiffness and strength, as well as reasonable energy absorption capacity, dampening, and insulation properties. As can be seen from the graph, the force level of the foam-filled shell is higher than the combined force of the shell and foam. This effect is referred to as the interaction effect, because the beak's energy absorption capacity and mechanical stability has increased significantly.
The section cut of toucan beak give us an idea of how to build the exterior of the helmet more rigid. By designing or overlapping the shape of cobblestone on the helmet will reduce the impact of collision. The properties of exterior elliptical scales will be 5 cm long in horizontal axis and 4 cm radius in vertical axis. At the same time, choosing the lightweight materials will maintain the feature of toucan beak, low density, and high stiffness. In order to test the practical value of the helmet in real-life situations, we put on the helmet on both egg and tomato. The result of our experiment demonstrates even the object with fragile surface will get fully protected by wearing the Beacon helmet.
We intend to use the Beacon helmet to provide better protection and shock absorption to patients who acquire cranial helmets. The toucan beak was built to be lightweight and strong, thanks to the beak's rigid foam layer that is sandwiched between 2 hard layers of fibrous keratin scales. Upon designing our new helmet, we decided to incorporate these beak features into our helmet design. Our new protective cranial helmet will be able to help people who are recovering from recent brain surgeries or are suffering from epileptic seizures, cerebral palsy, self-injurious behaviors resulting in head banging, or neuromuscular disorders that cause a loss of balance. Thus, our helmet will be able to absorb any impacts in order to protect against cranial contusions. Currently, there exist other cranial helmets on the market. However, none of these helmets are as lightweight, durable, or protective as the Beacon. Some of the most popular helmet choices force patients to choose between protection or comfort. Oftentimes, the most protective helmets restrict head movements and are very heavy and large. On the other hand, the most comfortable cranial helmets can often be too soft to the point where they do not offer adequate protection or ventilation. As can be seen from our innovative design, our novel helmet is a combination of the positive aspects of both the current helmet choices. This means that patients no longer need to choose between protection or comfort. Our lightweight, impact-resistant helmet, inspired by toucans, will be very unique when it is introduced to the market due to its ability to absorb and dissipate energy while also being comfortable and durable for wearers due to its foam interior.
Neurosurgical procedures like craniectomy often require a use of protective helmets during rehabilitation. Patients recovering from brain surgeries often suffer from symptoms like confusion, loss of function, and reduced mobility, which can increase risk of tripping or falling. Thus, a protective helmet is crucial in order to prevent re-injury during the healing process. Yet many patients forego wearing helmets simply because they are too bulky and uncomfortable, often turning to thinner, less protective cover-ups like scarves or turbans. Beacon provides the perfect solution for these patients, combining comfort, style, and protection with its toucan-inspired foam-lined shock-absorbing properties. Our product will ease the rehabilitation process, making sure that patients' lives are no longer hindered by bulky or less protective helmets.
Our next step is to collaborate with researchers and medical professionals to best suit the needs of our target demographic. By further studying the characteristics of toucan beaks with biomimetic researchers such as Yasuaki et al., we hope to accurately apply the shock-absorbing characteristics to our product. We also want to collaborate with existing companies that specialize in protective helmets such as Guardian helmets, Ortho America products, Comfy caps, and Opticool headgear to introduce our novel idea or build upon their existing models and add our bio-inspired design. One critical piece of information we need is proving its efficacy by performing numerous experiments. Because this is a medical device, we want to ensure it is as safe and durable as possible for our target demographic. Some roadblocks we may encounter are construction costs and slow production time. One way to address this problem is to consider 3D printing the helmets, which would also provide a faster turnaround from the time a patient submits their cranium specifications. In the future, we want to consider utilizing environmentally conscious material and using our product to address plagiocephaly, which is when an infant's skull is flattened in one area. It may also be worthwhile to consider bioprinting to biofabricate the keratin found in toucans.